In our discussions of ancient astronomers, one of the big problems that they dealt with was the motion of the planets. Chapter 3 of the book gives us some of the ways they figured out, the calendar, gives us some of the ideas they figured out about the size and shape of the Earth. Chapter 4 really gets us into discussing the way that the ancients figured out what was going on with the planets, or tried to. And it introduces the idea of the heliocentric or the geocentric models. But it also introduces us to the concept of retrograde motion. Now, what do I mean by retrograde motion? If you go out at night and you look at the moon, every night the moon is about half a constellation farther east in the sky. So it's always moving towards the east. Every year, Jupiter is about one constellation farther to the east in the sky. Saturn is a constellation to the east, it's a constellation to the east in the sky every 2 to 3 years, or every 2.5 years. And so this gradual eastward motion is what we call prograde motion. Even the sun appears to be a little bit over to the east every day relative to the background stars, which is why the background stars appear to rise and set 4 minutes earlier every day. All this eastward motion, doesn't matter what's moving eastward, that is called prograde motion. But they noticed, particularly with Mars, that every now and then Mars would be going along, it would stop, and then it would drift westward in the sky, and then stop, and then go back eastward. And so this backwards motion we call retrograde motion. And so it was moving to the west. The normal motion was to the east. Okay. And so sometimes it goes across the sky and stops, comes back, it goes forward, makes kind of a loop in the sky like it did back 2012, 2005 or so, or I guess 2005 it went back and forth, and then 2011 and 12 here it's doing this. It's making the little loop-de-loop. Okay, so this is for the planet Mars, and so this is what's coming. Okay, coming up here in 2021, 2020, or rather 2022, 2023. It's making a zigzag thing again. Okay, so this retrograde motion. Okay, and it's fairly startling because Mars moves roughly a constellation a month. And yet, all of a sudden, what will happen is it will spend several months in one constellation, just going back and forth. And so to the ancient people that were watching the sky, this was really something startling. And so they were trying to figure out, well, how does this retrograde motion happen? Now remember, Greek philosophy was considering the possibility that Earth was in the center and all the stars, planets, and everything were going around in these big, perfect crystal spheres. In fact, they talked about the harmony of the spheres, or the idea that the spheres would vibrate as they move past each other, and you have this unbelievably heavenly, beautiful music of the spheres. And so the idea of this idea of crystal spheres, and each one had a star, had stars or a planet painted on them, was a dominant idea. But what would make retrograde motion? Surely that you could not say that one of these perfect crystal spheres, slipped a cog or something and slid backwards. That didn't make any sense. So what was going on? So the idea, actually, interestingly enough, an idea they came up with to try to explain that was discovered by, or came up with, or hypothesized by none other than a fellow by Hipparchus. We already talked about Hipparchus. Hipparchus develops the magnitude system. He measured positions of hundreds and hundreds of stars, and he tried to figure out what could possibly explain this. And his idea was that maybe the planet moves around on an epicycle, and the epicycle moves around the sky. And so now he did this without doing any math, okay? And this is the problem, this is what differentiates philosophy from science. Okay, philosophy, I think it's that way. Okay, it must be that way because I think it is. Okay, a lot of politicians think that too. But science, you have to go through the math and say, well, I think it's that way. Let me work through the mathematics and see, does it really work that way? And so, but his idea was that the planet would do these little loop-de-loops like this, and if you're looking at it from Earth, it would look like it's occasionally moving backwards. And so this was kind of right here a schematic of that sort of thing happening. And again, it looks like without doing math, this idea would work to explain retrograde motion. The problem is, if you actually look at how circles work, and if you actually look at motion around circles, what in physics we call uniform circular motion, and look at the mathematics of that, look at the trig, the sines and the cosines that relate to position there, what you discover is that that does not actually describe this kind of a shape. Worse, it actually would appear to indicate that, if you use this to calculate, you'd get the wrong spot. So even if it did go backwards in the math, it goes backwards in the wrong spot for the way it does in the sky. So that means this is not the correct explanation. Well, other astronomers started working on this, say, well, maybe we need to expand this. We need to measure the sky better. And so they use all kind of instruments. Something called a cross staff was very, very commonly used. And basically it's like a long stick and a cross piece. And so the way you'd use the cross staff here would be that you would line it up so that you would see, there and up there, and you see two stars, and by knowing that separation and that distance right there, you can do a little trigonometry and calculate the angle. Okay, and so what would happen would be if you move the if you were to move the if you were to instead move the stick out near the end down here, then what would happen is that things would line up here and you would end up with a smaller angle. And so this would how you measured angles in the sky. They also built something called an astrolabe. The astrolabe is actually a very ingenious sort of thing. If you look at that carefully, it's got markings around the side of it. It's got like an artificial horizon in here, and it's got stars marked on here and coordinates. Well, you've seen something very similar to that. That's very similar to your planisphere, except the astrolabe is like a planisphere on steroids. It does a whole lot more than your planisphere does, and was actually used in some degree for navigation. Okay, and then they later developed something called a quadrant, which is basically like a fancy protractor to measure the sky. And then an improved version of that became a sextant. Retrograde motion really messed up our understanding, or at least the ancients' understanding of the sky, and because they were having a difficult time explaining that. Along comes an astronomer living here about 100 and something year, 100 and something, Claudius Ptolemaeus, or we generally refer to him as just Ptolemy. He was actually a Greek astronomer. He lived in Alexandria. Now, in the ancient world, Alexandria was noted for a library, the repository of all knowledge. It was like the internet of the ancient world. And so he worked and studied at the library and was studying everything that was known about astronomy. And he publishes a multi-volume encyclopedia of sorts called the Almagest. Now, we don't really know what he called it because there was a fire at the library and it burned up like the first volume or part of the first volume, which had the title, but Almagest comes from the Arabic meaning the greatest. The rest of his work survived and became a repository and a reference guide used for the next 1,000 years to understand the sky. He listed everything that was known, all the calculations, how you calculate where everything is in the sky, the brightness and locations of everything. In fact, his measurements and recordings were so accurate that over 1,000 years later, that Sir Edmund Halley was making measurements of locations of stars in the sky and realized that stars actually move in the sky, not just planets. And so this was the importance of Ptolemy's work. So he was trying to explain things, and he understood about the arguments that Aristarchus had, but he discounted those. And instead, his idea was that Earth was the center of the universe, center of the solar system. The moon went around, the sun went around, and that Mercury and Venus went around little epicycles on a line fixed between the Earth and the sun. So that means there was sometimes to the left of the sun, sometimes to the right of the sun. And then the other planets went around here, it went around epicycles also, because that seems to explain retrograde motion. But he also knew the math didn't work out right. So his idea was it went around an epicycle that went around an epicycle, which went around an epicycle, and so you put all these motions together, and if you had 30, 40, or 50 epicycles, then what happened was the math actually came out kind of close to what was actually going on in the sky. Now, he didn't know it, but he was actually inventing something from calculus that says that you can actually describe a function by having an infinite series of other functions. And so he didn't know that. Calculus had not been invented by that point, but he was accidentally leading into that by this idea. Now, obviously, this doesn't make any sense, because why would a planet go around nothing, and why would nothing also go around nothing? Because the epicycle is basically the planet going around a spot of nothing, and that spot of nothing would be going around nothing, and that nothing spot would be going around something. Okay, so epicycles and deferents. The deferent is the nothing spot that's going around, and then the epicycle is the actual motion. But this did not really make sense. He even acknowledged it did not make sense, but it was the closest thing he could come up with to explaining a way of calculating where you would see a planet in the sky. And so he wrote all this down, okay, and then bad things started happening. You had plagues, you had barbarians, you had all kind of other sort of things going on. Scientific investigations largely came to a halt. The Arabic world continued making observations and refining these observations, but they did very little to try to extend explanations as to why things changed. They just accepted that's the way that it was. But this became stagnation for a very long time in astronomy, until eventually they came up with a new way of describing the sky based on necessity to explain other things that weren't working right, namely the calendar. And so that's where we're going to go next, is how they started revolutionizing and coming to a modern understanding of the sky.